Hello students, today we are going to study chapter 3 of standard 8th, Force and Pressure. Force involves interaction or communication between two or more objects, and it causes push or pull between the objects. There is always direction associated with force. A stationary object means the object which is at rest. For example, a chair will remain stationary if no external force is acting on it. The chair is a non-living thing. It cannot move on its own. An object in motion continues to move with the same speed and direction when no force is acting on the object. This is Newton's first law of motion. Examples of this law are: the motion of kite changes when the wind changes. If there is no wind, then the direction of kite won't change. A book lying on the table remains at rest as long as no force acts on it. Force acts on two bodies when there is interaction between them. Example: a car moves in forward direction when a man applies force from behind. A reluctant dog is being pulled by his master. Here, the man is applying muscular force on the car and the car moves forward. Frictional force also comes into play. The boy is applying muscular force to pull the dog, and the dog is also applying muscular force trying to resist his owner. To bring motion in an object, force has to act on it. Types of forces. First, contact force. It is a force that requires contact to occur between objects. This force is involved only when two objects physically interact or touch each other. You can visibly see the interaction between the two objects. This type of force is called as contact force. Examples of contact forces are: first, coconut falling on the ground. Because of gravitational force, that is, the force exerted by the earth, the coconut falls down and touches the ground. Second, when you rub a comb on silk cloth or hair, electrostatic force, that is, the force produced in certain objects due to friction, generates, and the pieces of paper are attracted to the comb. When electrostatic force acts on the paper, the pieces of paper touch the comb. Muscular force is also an example of contact force. It is used for lifting, pushing, pulling, etc. Non-contact forces. This force acts on object without physically coming in contact with the object. In this force, you cannot see the interaction of the two objects. Example: magnetic force, gravitational force, and electrostatic force. Now, gravitational force and electrostatic force comes in contact forces as well. When the coconut falls down because of gravity, it touches the ground. There is a contact between coconut and ground. So, it is an example of contact forces. Can you see gravity acting on the coconut? Means gravity actually touching the coconut and making it fall down? No, we cannot see that. But the force is there. Hence, gravity comes in non-contact force. The coconut touching the ground because of gravitational force is an example of contact forces. The coconut falling in the first place is an example of non-contact force. Another example of non-contact force is magnetic force. Here's an activity that you can do at home. Take two plastic bottles with rectangular shape. Close their openings by fitting the lids. Keep two small bar magnets on them and fix them neatly using a sticking tape. Fill a big plastic tray with water and leave the two bottles floating with magnets at the top. Take one bottle near the other. If the north pole of the magnet is near the south pole of the other magnet, the bottle will head towards each other because the opposite poles or unlike poles attract each other. Now take one bottle and change its direction. You will see that same poles of two magnets face each other. After some time, you will start seeing that the bottles are moving away from each other. This is because like poles repel each other or move away from each other. This we have already studied in standard 6th and 7th. This shows that non-contact forces is present between two magnets. Frictional force. When two surfaces are rubbed against each other, force of friction comes into play. Example, when a ball is kept on a table and pushed a little, it moves ahead and gets slow and stops. Also, a car running on a plain road travels some distance and stops after the engine is switched off. This is because force of friction comes between the ground surface and object in motion. Frictional force is present in all the objects which are in motion. It is acting in the direction opposite to the direction of motion of the object. It is useful in daily life. It comes into action while walking, running. If there is no frictional force, we will slip and fall down. Balanced and unbalanced forces. These forces can be best studied by doing an activity. Take a cardboard box, tie thick string to its two sides and keep it on a smooth table. Take the strings on both sides of the table. Tie weighing pans to the two ends. Keep equal masses in both the pans. Refer to picture number 2. When an object of equal mass is kept in both the pans, the box kept on the table does not move. Equal gravitational force is acting on both the pans where objects of equal mass are kept. This means balanced force acts on the mass with effective force equal to 0. The gravitational force is equal to the force exerted by the box on the table. When you add more mass in one of the pans, the box starts moving in the direction of the pan which has more mass. When unequal forces are applied to the box on the two sides, an unbalanced force acts on the box, resulting in motion. Gravitational force is acting more on the pan in which more mass is added than the other pan. Forces that cause a change in motion of an object are called unbalanced force. Another example of these forces is children playing a tug of war pull the rope in their respective directions. If the pull of the force is equal on the two sides, the rope does not move. If the force is more on one side, the rope moves in that direction. This means that initially the two forces are balanced. The rope moves in the direction of higher force when the force becomes unbalanced. What do we understand from this? We understand that force is applied to change the position of a stationary object. Similarly, force is also required to stop an object which is in motion. Force is also applied to change the shape of an object. Inertia. Inertia is a tendency of an object to remain in its existing state. It means an object which is stationary or at rest will remain in the same state, and an object which is moving will remain in the same state of motion if there is no external force acting on it. Example, a book kept on a table will remain as it is until and unless it is moved. Types of inertia. First, inertia of the state of rest. An object in rest cannot change its state because of its property. It is a tendency of an object to continue its state of rest unless an external force acts on it. Example, the dust particles on the carpet are going to remain as it is unless you beat or shake the carpet. Another example is the first picture on the screen. A coin is kept on a cardboard. When you flick the cardboard, the coin drops straight into the glass. This happens because when force was applied to the cardboard, coin was in state of rest. It continues to be in the state of rest due to inertia. Hence, it falls into the glass. Second, inertia of motion. If a body is in a state of motion, then it will continue to move with the same speed and direction unless an external force acts on it to change its state. Example, passengers sitting in the running bus gets a jerk in the forward direction if the bus suddenly stops. Third, directional inertia. The property of an object due to which the object cannot change the direction of its motion is called directional inertia. For example, if a vehicle in motion along a straight line suddenly turns, the passengers sitting in it are thrown opposite to the direction of turning. Pressure. Pressure is a force applied perpendicular to the surface of an object per unit area. SI unit of pressure is Newton per meter square. It is also known as Pascal. To understand pressure in a better way, let's do an activity. Take some sharp pointed nails and push them into a wooden plank by hammering on their heads. Now, take a nail and hold it with its head on the plank and hammer it down from the pointed end. What does this simple experiment tell? The nail easily penetrates into the wood from its pointed end, that is, the tail end of the nail. But when the head end of the nail is kept on the wood and when it is hammered, the head does not easily penetrate into the wood. From this you will notice that when a force is applied on the head of the nail, it is easy to hammer it into the plank. If area increases, pressure reduces for the same force. And if the area decreases, the pressure increases for the same force. Pressure on solids. When a weight is kept on a solid, pressure is exerted on it. The pressure depends upon the value of the weight and the contact area between the two. Example, skiing. Skis are designed to minimize the weight of the person pushing down on the snow so that the person doesn't sink in the deep snow. Skis have large surface area. This helps the force to spread out. Here, force is the weight of the person. This lowers the pressure as the area increases. When books are kept on a table individually, the weight of the books is distributed on the large surface area of the table and not much pressure is applied on the table. When the books are stacked on one another, the net weight of the books increases, means more force is exerted. Since the books are stacked, the surface area of the table on which the books are kept becomes small. The force becomes concentrated and large pressure is applied on it. Pressure of liquid. Liquids exert pressure on the walls of the container. Water pressure is equal in all the direction. The water falling from hole near the top is at shortest or closest to the bottle, and the water coming out of hole which is near the base is farthest from the bottle. What do we understand from this? Water comes out of the bottle because of water pressure. Water coming out of the hole nearest to the base goes farthest. So this means water pressure increases with depth, meaning water pressure increases with the height of the water column. Water exerts equal pressure in all the direction at equal depth. We can say that as the depth of the water increases, the pressure increases. Gas pressure. The pressure of a gas is the force that the gas exerts on the walls of its container. If a balloon is blown by filling air by mouth, it inflates on all the sides. If a pinhole is created in the balloon, air leaks out and the balloon does not inflate fully. All the gases and liquids have a common name, fluid. Fluid in a container puts pressure from within on the walls and the bottom of the container. The fluid exerts pressure in all directions. Atmospheric pressure. It is the pressure which is created due to air. Imagine that a very long hollow cylinder of unit cross-sectional area is standing on the surface of the earth and it contains air. Gravitational force is acting on the air and pulling it towards the center of the earth. So this becomes the weight of the air, because weight is nothing but gravitational force acting on an object which has mass, and air has mass as it is made up of different particles. This means that atmospheric pressure is the ratio of this weight divided by the area of the surface. Air pressure decreases as one goes up in height from the sea level. This is because high altitude places do not have much air about them pushing down. Air pressure increases when there is more air in a particular spot. Where the layer of air is thinner, there is lower air pressure. The unit of atmospheric pressure is mbar or hectopascal. The atmospheric pressure is equal on all the sides. But how is this air pressure created? If air exists in a closed container, the air molecules in random motion continuously hit the walls of the container. In this interaction, a force is exerted on the walls of the container. Pressure is created due to this force. There is constant atmospheric pressure on our heads. Human bodies are used to air pressure. Our body cavities are filled with air and arteries and veins are filled with blood. The air pressure in our lungs, ears and stomach is the same as the pressure outside of our bodies. Therefore, we do not get crushed as air pressure is balanced. Buoyant force. To study buoyant force, let's do an activity. Take a plastic bottle and fix the lid tightly. Now, place it in water and see. It will float on water. The empty bottle floats on the surface of water because weight of empty bottle is negligible as compared to the weight of the water. Now, fill the bottle with water to the fullest capacity and close the lid and release in water. You will see that the filled bottle floats inside the water, but it does not touch the bottom of the container. Why does this happen? Gravitational force is acting on the bottle and it tries to bring down the bottle. But there is another opposing force in the upward direction on the bottle filled with water. This force is originated from the water surrounding the bottle. The upward force acting on the object in water or other fluid or gas is called buoyant force. This force comes from the pressure exerted on the object by the fluid. We have always learned that if an object is heavier, it will sink in water. For example, an iron nail sinks in water, but a feather does not, because iron nail is heavier than the feather. But have you ever wondered why a massive steel ship or cruise ships float on water? When the ships enter the water, gravitational force acts on it. But, however, for the ship to float, displacement should be taken into consideration. When an object enters water, it pushes out water to make room for itself. The object pushes out a volume of water that is equal to its own volume. This is called displacement. Example: when we put ice cubes in a glass of water, the water in the glass rises. Means the water is displaced or pushed away to make space for ice cubes. Gravitational force tries to bring the ship down, but buoyancy force pushes it upwards. It is easier to swim in salt water than fresh water because the density of salt water is higher than fresh water. Because salt water contains many dissolved salts. Buoyancy force depends on two factors. First is volume of the object. The buoyant force is more if the volume of the dipping object is more. Second, density of liquid. More the density of liquid, more is the force of buoyancy. Archimedes principle. To study this principle, let's do an activity. Take a long rubber band and cut it at one point. At one of its ends, tie a clean washed stone or a 50-gram weight as shown in the picture. Now hold the other end of the rubber band and make a mark there. Keep the stone hanging in air and measure the length of the rubber band from the stone to the mark made earlier. Now take water in a pot and hold the rubber band at such a height that the stone sinks in it. Again, measure the length of the rubber band up to the mark. What is observed? This length is shorter than the earlier length. While dipping the stone in water, length of the stretched rubber gets slowly reduced and is minimum when it sinks completely. What could be the reason for a shorter length of the rubber band in water? When the stone is sunk in water, a buoyant force acts on it in the upward direction. The weight of the stone acts downwards. Therefore, the force which acts on it in the downward direction is effectively reduced. The use of Archimedes principle is very wide. This principle has been used in the construction of ships and submarines. The instruments such as lactometer, hygrometer are based on this principle. I hope you have understood this lesson. Thank you.